Yes, I do. Yeah, but it is very fun.
Good.
Yes, let's get started. Welcome everyone to Cloud Data Driven Online User Group. As you already know, our topics for today is SQL Server Performance Tuning. Who am I? I am Jean-Joseph, currently working as a data engineer. I've been in IT for over 18 years. I'm located in New Jersey and originally from Haiti, and I'm your host for today. The rules are you guys are free to comment, but you have to do it with respect. There must be no offensive comments. I have your video turned off. However, you do have access to unmute yourself. If you have any questions, I would highly suggest you to raise your hand and the speaker will do the needful, okay? We'll respond to your questions. We're gonna grant you access to ask your question. And then I also disable your the chat panel. I disable it just to have you, just to give you access to interact directly with the presenter. Let's connect it. Follow us on social media at Cloud Data Driven, and also please visit our data community for latest update. Go to datasaturday.com. There's a tons of other event out there. You guys are free to go and register yourself. And then there's another one which is SQL Saturday.com, and we would love to say thanks to Redgate. Guys, you are free to go and visit these two websites. And then also don't forget to register for Future Data Driven Summit. We have a tons of great sessions related to data and AI, machine learning, DevOps, data apps, Power BI, data visualization, integration, cloud infrastructure. I would highly suggest you to register and share this event with your peers as well. Today's presentation, as you already know, it's on SQL Server Performance Tuning. We have Hilary Cotter. He is one of my favorite speakers when it comes to performance tuning, right? And I think we know for quite, we have met for a long time, right, Hilary?
Yeah.
Yes, and it's an honor to have you here, Hilary, and thank you for your presentations. Hilary is a data platform MVP. He's a speaker, writer. He specializes in Microsoft search solutions and high availability technology. He's gonna tell you more about himself, right? And then if you guys, we do have a tons of other presentation lined up. The next one is Nicola Illich. He's gonna give you a crash course on Synapse Analytics for Power BI developers. Guys, don't miss this out, right? And then the next one is Kevin Klein, which is query tuning internal for the advanced SQL developer. You guys should reserve yourself as well for that. If you guys want to present a session, so we will be happy to set up a date for that to get you access to present your sessions. You are free to email us at jean.joseph@bigdatadriven.org, right? And I will respond with the just provide us your availability, your session presentations, abstractions, and summary. Then we're gonna work on that and schedule you. With that said, we would love to say special thanks to all attendees, especially to our presenter, which is Hilary Scott, right? Hilary, the floor is all yours. You are free to share your screens, introduce yourself, start with the presentation.
Thank you, Jean. Okay, so let me just share. Oops. Don't think I've shared my screen correctly. Let me try that again. Okay. We can't see. Hang on 1 second. I did share my desktop.
It's okay. Can you guys keep yourself muted, please? Thank you.
All right, let's try this. Can you see that? All right, so
Yes.
thank you, John. This is a session on SQL Server Performance Tuning. What I did a lot of was I would work for various companies, and they would call me in when they had performance tuning problems. So I would typically have to walk in to a shop which I probably wasn't that familiar with. So what I wanted to do was I wanted to give you some of the techniques which I've learned over time, and then I want to start talking about best practices. Okay, so we've already talked about who I am. These are some of my clients. What we're going to do is initially talk about triage, find out what is the problem, how to fix it, talk about some baselines. What you want to do is you want to know what changed. So sometimes you'll have code changes. Sometimes what you need to do is you need to look at the internals of SQL Server, the metrics of SQL Server, and find what has changed there. For example, are you doing more parallelism? Is your number of memory grants higher? Do you have more users? So you want to figure out what a baseline is so you can find out exactly where the pressure has changed on SQL Server. Then we'll start talking about some tuning basics. And we'll go into how SQL Server will execute a query, which is fundamental. Fundamentally knowing this, you'll be able to understand how SQL Server works, and you'll be able to tune accordingly. So typically, when you walk into a shop for the first time, you're clueless. You don't understand what is going on. So you need something to tell you exactly where the pressure points are, to relieve these pressure points so that you can get overall performance. SQL Server gives you so much data that quite often you're just overwhelmed and you just don't know what to look. You don't know where the particular stressor is, and it's very, very hard drilling down on what the particular problem is. What we're going to do is we're going to go through some sequences, some code samples to help you determine where the pain point is. So first of all, we're going to talk about triage. What I'd love to do, first of all, is if I'm called in to look at something, I like to look for blocking. Is there a specific process which is blocking your ongoing workload? I'd go back. So I do select star from sys processes were blocked is not equal to 0, and I order by wait time descending. And quite often what you'll find is you'll find what is causing the blocking, what we call the lead blocker. And you may evaluate killing that, or you may talk to whoever owns the application to find out what you can do with that. Keep in mind that blocks can be held forever. So if you have a lead blocker, that block may be held forever until you restart SQL Server. So typically what happens is you will see some blocking, but it will be satisfied. So the block process will finish its work and then go away, and other things will finish.
Okay, well, we'll have to.
Right. If you see a particular block being held by a process, you may want to find out what that process is doing. So you want to find the particular query that it's running. So what I do is I do select star from sys.dm _ ex _ input _ buffer, and here I'm putting 51. Processes below 50 are system processes. So you can't really do a lot with them. But user processes, which are greater than 50, are things you can sometimes do things about. So what this particular query will do is it will tell you the particular SQL statement that is running. Also an XP read error log. What that will do is it will dump the error log to me. And what you should be doing on a well-managed system is you should be cycling the error log every day. Some places will not cycle their error log, and so you have a very, very large error log, which is regenerated every time SQL Server starts. So running this may take some time, And then what will happen is eventually you will get a screen full, which is the last entries. And just look through that and see if there's anything important there. You may find that read IO operation has taken more than 15 seconds to complete. It may say things like the cache has been flushed. They give you indications that there's memory problems. I love to run something called SPWhoisActive. This is from Adam Mechanic. If you go to spwhoisactive.com, you can find this particular stored procedure. You can run this, and it will rank queries according to how long they've been running for. So the first query, it'll give you a basic result set. The first query will tell you, the first query that will show up is the longest, the one that's been running the most longest. It will also show you blocks, and it will show you Tempdb allocations. It shows you a lot more information, but these are the ones which I look at. Now, Tempdb allocations are a sign that Tempdb is, the particular query is using Tempdb a lot. So it may be doing something called Tempdb spill. It may be just allocating a lot of memory for itself to run. But these are things which I look at in order to figure out, well, what is causing the problem here. So another stored procedure called SP pressure detector. This is something by a guy called Eric Darling, who I think is one of the best performance tuners out there. He does free videos on YouTube, and he sells videos at darlingdata.com. So he sells his training courses. Very good guy to watch the videos of and attend his presentations. But this will tell you things like if you have memory problems in your SQL Server, or if you have processes which are waiting on CPU. So you may find that when you run this, you have what's called thread pool errors or thread pool wait stats. And what this means is that your SQL Server is processing a workload that is consuming a lot of CPU. And you have processes which are waiting to run because there's not enough CPU cycles for them. It'll also tell you things like resource semaphore. Resource semaphore means that you don't have enough memory to process your requests. So you may have a query which is running, which is sucking back a lot of rows or doing something which is very, very inefficient. And to do that, what it has to do is it has to say, I need this amount of memory. And it may take up to 1/4 of your system's physical memory that you've allocated to SQL Server. So at query may demand that amount of memory. And SP pressure detector will tell you that. So if you have some reporting queries which are running, you may find that some of them are demanding huge amounts of memory, and then the rest of them are waiting to run, but they don't have enough memory to run it. So you will have the resource semaphore wait stat logged through SP pressure detector. Query store, we'll be talking about query stores today. Again, it's kind of in-flight data. It'll give you information. It's like a black box into SQL Server. It'll give you a lot of information about what's going on in SQL Server. SP Quickie Store. This is a stored procedure, again by Eric Darling, which adds functionality on top of the existing Query Store. Query Store ships in SQL 2016 and above in every edition, Express all the way up to the Enterprise edition. I also look at wait stats. When a query runs, what it will do is it has 4 milliseconds to run in. After 4 milliseconds, it is put on a wait queue or runnable queue, and then it goes back to run again. So ideally, it'll just go through. It'll be executed. Then it'll go in the runnable queue because it's not waiting anything, and then it'll come back and go back on the running queue. If it's waiting on memory or waiting on IO or some other resource, what happens is it will run. It gets its 4 milliseconds to run in. It doesn't finish running. SQL Server logs what it's waiting on: IO, memory, CPU, network IO, and then that wait stat is logged. And then it goes in the waiting queue. When whatever resource it's waiting for it is available, then it goes on the runnable queue, and finally it gets some execution. Now, what you may find is that in certain cases, you may want to update statistics on certain tables. You may find that some branches of a parallel plan are not executing, they're kind of skewed. And some of the threads complete, but they're waiting on one particular thread. This is because statistics are not up to date. You may also find incorrect memory grants. So statistics are very important to keep up to date. And you may find yourself in a situation where you want to update statistics on demand for a particular table to get the kinds of execution plans that you want. SP recompile will recompile a stored procedure. If you detect that a stored procedure is running longer than its baseline, you may want to run SP recompile on that particular stored procedure. You can also run this on a table. And what will happen is it will mark that table as having changed in some way. And every stored procedure touching that table will be recompiled. If you do run it on a table, you have to watch out because it may take a very long time. It may cause some blocking on your system. And if you cancel it, you are canceling a transaction and you'll have an open transaction. So you have to do a rollback tran if you do cancel SP recompile against the table. Glenberry has some diagnostic queries that he always updates for every CU. You can go to SQL Skills and get that, or just query on Glenberry diagnostic queries. And this will spit out information that Glenberry uses when he's doing performance tuning, or he's called in to do diagnoses on poorly performing SQL servers. And it will run through all sorts of diagnostics. And with each diagnostic query that you run, he will tell you that this particular, that what you should expect is this sort of results that coming back. If you get anything out of that, you may be facing a problem with memory or IO or CPU. If you do like Glenberry's queries, you can run something called from DBA tools, which is a set of PowerShell commands, PowerShell library, and you can do invoke DBA diagnostic query. And what this will do is it will export all of Glenberry's diagnostic queries into a file system so that you can bring it into Excel and look at it yourself. All right, so these are things which I do to triage situations to find out what's going on very quickly. Ideally, what I will have is I'll have some baselines. You can use Performance Monitor to collect baselines. A really good tool is Clint Huffman's PAL tool. We'll look at that in a moment. RML utilities and database experimentation assistant. Database experimentation assistant is really the version of RML utilities that works after SQL 2014. Before SQL 2014, you should be using RML utilities to create these reports, which I'm going to show you in a moment. Now, I have to cancel that, and I have to share a different area of my screen, so just bear with me for 1 second here. Trying to share my desktop. I'm not exactly sure. Just 1 sec. Hopefully I can find my, well. Gene, do you know how to share your entire desktop? All right, I'm gonna have to go back. Let me just show this screen here.
Click on share content.
Yeah, I did do share content, but that doesn't seem to do everything.
You're trying to share
I want to share my desktop.
Or desktop.
I want to share my desktop.
Click on share content.
So in presenter mode, and I see presenter mode, content only, standout. I see screen, I see windows. Let me just quickly show the Excel spreadsheet I want to show you. Here we go. All right, good. So RML utilities will spit out a report like this. It shows 4 quadrants. These quadrants are CPU, duration, total reads, and total writes. And what you can do is you can say, oh, I see this guy here is 162 executes. This one here is 1,467 executes. So I probably want to look at query number 3, and I want to tune that. So here it is here, get pending thumbnail images. And then I can crack that code open, and I can go and I can tune that particular branch of code. So what you want to do is you want to run this, and you can run this as a job. You can run retrace as a job, and that will generate these reports on a regular basis. You can store them in a database. And this way you can find out, well, this stored procedure typically has been executing. I see this as executing 1,467 times. Well, last week it ran 1,467 times in this collection period. This week it's running 5,000 times. So you know that this is what has changed on your system. Now I want to share the PAL tool report. So just give me a second to share that. All right, can you see this?
Yes.
Can you see the PAL report? Probably not. Let me go back and
It's
share.
loading.
Darn it. All right. Here it is here. So this is what we call a PAL report. There's a tool you can get from GitHub, written by a Microsoft engineer. And what this will do is it will show you where which particular hardware component you're stressing. So I click here.
I'm not seeing your screen, Hilary. Sorry about that. Yes, now it's loading. I just want to make sure.
All right, super. All right, so you can see that now. So this shows that SQL Server is using more than 30% privilege mode. Greater than 20 work files, probably problem with Tempdb. You're probably running some query, which is hitting Tempdb a lot. All right, so, and I see average lock wait time is about 750 milliseconds, again, indicating I have a locking problem. And what this turned out to be a problem with parallelism. So I'm going to show what we did real fast. So I have to stop sharing, share, and hope I can find this real fast. Darn it. All right, Sean, we have to figure this out. I just don't quite know how to do that. Darn it. Let me just try to share again. How do we share the desktop?
You just click on share content. You will see
I
screen.
see standout.
Yeah.
Do standout?
There's
all right, yeah, this is what I want. Okay, great. Okay, so what I want to do is here. That's not. Can you see it? Super. Okay, so so we saw a lot of work files being generated in that last report. What we see is I'm looking at the wait stats here, and I'm seeing CX packet. So I'm seeing it very high here, and then after I fixed it, it became much lower. So this was CX packet. What I did was I put an index in, and by putting that index in, we were able to make everything work well. So I started off with a PAL report. the PAL report said where I was stressing IO. And then I also looked at wait stats, and with wait stats, I was able to find a high CX packet. I was able to figure out the store procedure and the table that was giving the high CX packet. And then I was able to create an index, and boom, we were in a good place. Okay, let's go back to my presentation. Okay. All right. So what we've done is we've gone over some, oh, darn it. So we've gone over some, we've gone over some triage things, what to do when you have a problem and how to immediately fix the problem, how to immediately zero in the problem. Then we've started to drift into best practices. Best practices are perf mod, so you can find out, are you running higher CPU than before? Is your disk slower than before? Use the PAL tool. The PAL tool will tell you which specific bit of hardware you're stressing. So you can figure, well, I am hitting CPU a lot. It's a problem with parallelism or whatever that is. RML utilities, they tell you each individual stored procedure, and they rank them. So you know, if I work in this one stored procedure, I'm going to have the most impact on the system. Again, database experimentation assistant does the same thing as RML utilities. Both of them spit out those reports. You can run these as jobs and collect this information over time. So tuning basics. The response of a query. So how long it takes a query to run is how long it takes for that query to run when it has SQL Server running it, and how long it has to wait for. So tuning should start with the largest time consumer. So if your workload is characterized by CX packet, then what you have to do is you have to say, well, maybe I should add some more indexes. Maybe I should change the cost threshold of parallelism to stop it from stop parallelism from kicking in so much. Or maybe what I should do is update statistics. There's a variety of approaches to this, but start with the wait time. Start with what it's waiting on the most. And you want to find out, is your process spending all its time waiting, or is it spending all its time being serviced by SQL Server? If it's spending all its time waiting, well, you have to look at your server as a whole. If your process, if your query is spending all its time executing, well, then you have to look at your stored procedure, your query, to see what you can do with that. All right, so what happens is SQL Server will take the processors that you present to it, and it will divide them up. So here we're looking, and we see we're in a 4-proc box, because I see scheduler ID 0123, and then I have some hidden ones, which are used by the SQL Server OS itself. And I see the DAC ones. So if you ever see a non-yielding scheduler, that means that one of these user schedulers should have given itself back to SQL Server after it's 4 milliseconds, but for whatever reason, it didn't, so it got hung. So that's what that is about. So breaking this down, we see that there's some hidden, there's some visible, and there's another visible online, which is the DAC one, which you should be using for diagnostic purposes if your server is hung for whatever reason. So SQL Server, in this case, only has 4 processes that it can work with. Now, so again, we started talking about this, that each task can run on one of those processors, or it can consume all 4 of those processors. So if you're running parallelism, or if your query is running 2 or 3 branches at the same time, that may consume 2 or more of the processors. So it may run in 2 or more of the processors. This means that if your query is running and it's a pig, it's consuming a lot of processors, everything else has to wait. If your process is only consuming 1 process, then you can have a total of 4 processes running at one time. So each task is considered to be a batch. So what happens is the request goes to SQL Server from your client, or maybe from SMS. It goes as a task and it's pending, it's compiled and executed. So the status, if you look at sys.dm.exe request, you'll see the status is running, runnable, suspended, background, or sleeping. So what happens is, if I'm running a query and I say, oh, I need all this memory to run, I need the memory grant, what it does is it runs for 4 milliseconds. It needs more memory, so it goes to suspended. It goes to suspended queue until that memory grant is satisfied, and then it goes back in the runnable queue. And then when those 4 processes which are currently running are finished, then it will go, that query will go into the running queue. So if you have to wait, it goes into DM waiting tasks, and whatever it has to wait on is logged as the resource wait. Signal wait is how long that query in the waiting task takes to run after that resource is satisfied. So for example, if we have a query, this query is running, and it's taken off the running queue, put in the suspended queue, then, and it's waiting on disk. The disk operation completes. It's going to be in that. It's going to be in that runnable queue until it gets cycles to run again. This is what we call the signal queue. Now, what you may find is that a query logs a wait stat as SOS schedule yield, or you may look at your wait statistics, wait stats for your query, for your server, and you may see that the most prevalent wait stat is SOS schedule yield. What this probably means is that your query gets 4 milliseconds to run. It runs it on the running queue. Then it goes onto the runnable queue, and then it goes back to the running queue. So it just cycles back and forth like that. So that is possibly what it means. It could also mean that you're having something called a spin lock, because having 4 milliseconds in the running queue, then going to the runnable queue and coming back, that's a lengthy operation. So what SQL Server will do is it'll give a process 4 milliseconds to run. It doesn't complete in that 4 milliseconds because it's waiting on something. So what it does is it will do something called, it'll go in a spin to see if that particular SQL Server resource, internal resource, is available. And if it is available, then it will give it more execution time within that 4 millisecond quanta. So these are what we call spin locks. And so just because you have a high wait stat for SOS schedule yield doesn't necessarily mean that that everything's fine. So let's talk about how SQL Server modifies data. What happens is SQL Server uses something called write-ahead logging. So what will happen is you make a change. That change is written to transaction log buffer, then it's hardened to the transaction log. And at some point in time, a checkpoint is written. When a checkpoint is written, then what happens is SQL Server marks a checkpoint occurring in disk on the log, and it also will flush the dirty pages to disk, to your database disk. So what will happen is if your server ever abruptly stops, what SQL Server will do is it will go through the transaction log, and it will get to the last checkpoint, and it will see that there's some transactions which did not complete, and they are in the transaction log, and they're written to the database data files. So it says, well, these did not complete, so it has to dig them out of the data pages. Some transactions will have completed in the transaction log, but are not in the data pages of your database files. So what it has to do is that it takes those transactions and it writes them to the transaction log. I'm sorry, it writes them to the database pages. So this way, everything's consistent. You don't lose data. Now, so basically, what happens is everything is written to the transaction log, and at some point in time, it's persisted to the transaction log. This is something that SQL Server is waiting on. That particular wait stat is called a write log wait stat. So SQL Server, so everything in SQL Server is either waiting or executing. And what you want to do is you want to maximize the time that everything is executing, and you want to minimize the time everything is waiting. And again, you want to pay attention to wait stats because that tells you what it's waiting on and if there's anything you can do about it, like faster hardware, or if you're waiting on parallelism, 6 packet wait stat, if you're waiting on parallelism all the time, maybe there's something you can do about that. We'll talk about that in a moment. DMEXCC requests, this will tell you what is running at any one time. So what I want to do now is I want to kind of look at a session. So what we have here is we have session 53. Session 53 is blocked. It's waiting on session 56. It can't run because session 56 is stopping it. It's waiting on a lock MS wait type, and it's waiting on a key. So it's trying to write to a key. It's trying to write to that key, but it has to wait for it. 56 is suspended. So it is waiting to write that transaction to the transaction log. So, so it's 54. We see that 54 and 53, that 54 and 55 are running, and they're cycling back and forth in the runnable queue, in the running and runnable queue. And what's happening is 55 is not waiting on anything right now. The last time it was waiting on a page latch, shared paired page latch. All right, so let's look at this one here. So what happens here is session 53 is a commit transaction. So it's running to the transaction log at this point in time. That's this wait step is not being blocked, but everything else is blocked. It's blocked by session 53, which is committing that transaction, and it's waiting on session 55. Again, we have a shared lock wait on a particular part of an index. Okay, so what we can do is we can look at DMOS waiting tasks and we see what is waiting, and this shows us that 53 is waiting here. It's waiting on the transaction log write to be completed. 57 and 54 are waiting on some locks to be released. So this is our wait stats. So what happens here is we're seeing some things go on here. We're seeing SOS schedule yield, and we see that that we have a lot of waits on that, and we're seeing that we basically waited about 2.8 seconds for that to complete. Now we have some other wait stats here, which are listed, but they're not significant. So again, this workload here, ignoring the non-significant ones, this wait log here, this workload here is characterized by SOS schedule yield because that is the highest wait type here. All right, CS packet, that's parallelism. What that means is that SQL Server wants to run this query, wants to run it efficiently. So it says, well, the way I can run this query faster is by throwing more processors at it. So what it does is it, instead of running on one processor, it's going to run on multiple processors. This should be a good thing, but it's not always a good thing, because what can happen is a query can take up all of your processors, and then everything else has to wait for it to finish, and it can take a very long time. So to maximize concurrency, what you want to do is you want to set your maximum degree of parallelism to a low value. Some people will set it to 1 to maximize that, and they got no parallelism at all. To minimize performance, again, you want to set this to a low value. So let's look at how this works. So what I have here is I have one query which I color red. I have another query which I query orange, yellow, green, and so on. So when max stop is 0, this particular pig of a query can run on all processors. When it's 1, what will happen is I can have 8 processes running on the 8 processors. When it's 2, well, I can have 4, 3, and it goes on like that. 8, if I set it to 8, max stop is set to 8, well then my one query may run on all my processors. So here is what we see. We see a SPID 74, last wait type is CX packet, and we're seeing an uneven amount of CPU being utilized and an even amount of physical I/O. And this is most likely because SQL Server made a bad choice in dedicating the threads to this. And so we're having some skew going on. Ideally, everything would be running simultaneously. Sorry, my wife's on Alexa. All right, so what you want to do is you want to so parallelism is typical of data warehouse and OLAP queries. It's needed to process a large number of rows, but it tends to be a bad thing in OLTP. It tends to minimize throughput on OLTP systems, on large transactional systems. So it can be caused by local table variable use, bad execution plan choices, missing indexes, out-of-date statistics. It can be caused by bad search arguments, like here we have call 1 multiplied by 20 is equal to call 2. I'm sorry. All right. So then we have Jonathan K.S. Talks about how to tune the cost threshold for parallelism. By default, it's 50. You may want to set it to something higher, which means parallelism will not kick in until until a higher value is reached. Now, this particular query also talks about how to drill down in your procedure cache and find missing indexes, finding high count queries using parallelism, and fixing those particular queries. Knee-jerk is to set max view parallelism to perhaps something low, perhaps cost threshold of parallelism is something high. I've worked on some shops which had that set to 1,000. Again, not a good idea. It means that you're not getting any parallelism at all. And of course, these systems were not characterized by high CPU. High CPU can be indicative that you have a lot of parallelism going on. All right, page latch IO, page IO latch and page latch. Page latch tends to be a problem with not enough Tempdb files. Page latch IO means that you're reading a page off disk and you're allocating that in the buffer pool, and you're using a page latch, so no one else can touch that as that data is read off the disk. So normally it's a page IO latch, and then it's converted to page latch X. Whoop. All right, so these are spin locks. Again, if workloads characterized with very high SMS schedule yield, it can be that you're having a problem with these spin locks, these processes which SQL Server is given a chance to run within the 4 millisecond quantity. It can't quite run because of some reason. So instead of going back in the runnable queue, it just waits and then it will spin to try it again. Here we have a lock hash problem. We have a lot of spins, a lot of backoffs. It goes to run. It can't run because of some collision. So then what happens is it goes back. It's backed off, and then it runs again just a few microseconds later. This workload is characterized by a lock hash problem. So there's something wrong with some of your indexes, probably in this case. Okay, so what's the problem? So you have to ask yourself, what is the problem? Is my server slow, or is a particular query bringing down my server? So wait stats will help you figure out, well, I do have a problem with hardware. The PAL tool, again, will point out that you have a particular problem with hardware. The wait stats query, that will tell you you may want to throw more processes at, more memory at it, but likely you want to look at your queries and figure out how to tune them. Okay, so I want to talk about a particular query. There was an outage in 2016 in Visual Studio Online. So what we see here is we see red and blue response times. So we see these are climbing. What happened? This is what Visual Studio Online looked like before. So it was characterized by high CX packet. Now they made a change to their server, and what happened was suddenly their workload was characterized instead of by CX packet by resource semaphore. This is some of the queries running, and they demand a high amount of memory to run, large memory grants, and SQL Server can't satisfy all those memory grants. So what happens is it has to wait for the memory, and the wait type is resource semaphore. So here, this is our basic response times for that SQL Server. Again, you see it's very, very low. Going into 2016, 120, it suddenly went sky high. Here's a particular query. So here's what it looks like. This is a specially crafted query by Microsoft query engineers. And what they're trying to do is they're trying to force a certain plan because they want to use this index. Force seek again to use seek on that index as opposed to a scan on that index. And they're optimizing for partition unknown. And you see here that max grant percent in yellow is 1. What happened here was they said, I know you want a large memory grant, but I'm just going to give you 1% of what you want. And that's what brought it down. So when you want to find out a query, which is bringing down the server, use activity monitor, sys processes, probably my favorite. Glenberry diagnostic queries, also SP-Who2, which I actually probably use more than sys processes. You can use this query to tell you top IO resource consuming queries. Blocking, here's where you find out about blocking. Wait stats, this is how you find out what SQL Server is waiting on. You can clear them at any time by the last query. All right, so what I want to do now is I want to talk about, do a couple of demos here. So the first demo I want to do is this one here. Okay, so I'm using the credit database, and everyone says how bad select star is. So let's just do this. And I hope I said, yeah. This tells me the IOUs, and I see that I use 400. I use this amount of IO to satisfy that query. Let's do this. And we see almost the same amount of IO. So select star isn't necessarily as bad as people think. So let's look at this query here. Oop. Let's look at it again. Here I see it. Whoop. Oh, there. And what I want to do is I want to create an index on that. So I'm going to make sure it's not there. And now I'm going to create that index. Remember that I've recorded the IO here. So what I'm going to do is I'm going to create an index. Because I'm searching on charge date, I'm just going to create it like that. All right, so remember that this query took 9,453 IOs to satisfy. And now it took 871 IOs to satisfy. So that index was a good one. So let's look at this one here. So what I'm doing now is I'm selecting member number and provider number. Now look, this query took about 6 seconds to complete. It only used 156 milliseconds of CPU time. So most of that time, actually, let's just do this here. So remember, it took 5 seconds. Most of that time was bringing results back to the client. So I ran it again. Now we're getting something more realistic. So all that time was spent bringing the results back to client and displaying them. Okay, so let's do this query here. So again, I see the similar IO for that. And so what I want to do is I want to craft a special index for this that will give me better IO and a better response time. So 169 milliseconds, CPU time 377 milliseconds. So it used parallelism. That's why we got less elapsed time. So what I'm going to do is I'm going to create index on I guess say charge date. And I can put so I'm going to make this guess here as what this looks like. Order them accordingly. So what I do is I select here we go. Whoop, charge amount. Okay, so I see I have far more values here than here. So because this is going to be more selective, I'm going to put that order in first. Now, oh, already exists, so. Now, just for kicks, what I'm going to do is I'm going to reverse that. So we've created 2 indexes, and now what we're going to do, and I think this is the better one because I think this is the better one because charge date is more selective. Okay, here we go. Ooh. All right, so still 943. I'm not sure what's going on here. Actually, I know what's going on here. So we have these 2 indexes. What I want to do real fast is I want to say, okay, whoop. What I want to do here is I want to see which index was used. So we see that it's still using the clustered index. So it's not going and using these two beautiful indexes I created for it. Now, what happens is SQL Server is saying, well, I need the member number and I need the provider number. So rather than using these two beautiful indexes I created, I am going to query the entire table and get it from there. So what we're going to do in these two values in here, these are called included columns. So what will happen is at the leaf level of these indexes, these data pages are going to be stored. Okay, let's look at how this works now. So remember, last time we ran this 9,000 rows, 9,000, it was about 9,400 IO. So now let's look at it. Okay, now it's 1727. So it's much better. And let's look at what was picked here. So what happened is they're using the charge date because it's more selective, and then the charge amount. Now further, what we can do is we can create a filtered index on this. So let's, knowing this, let's see, charge amount inc. Where charge greater than 20. Yeah, I call it FLT. Oh. Whoa. All right, remember the last time we ran it, it was 1727. Let's look at what it is now, 1727. So is it using, it's not using the filtered index. Okay, actually, not sure why this is occurring. Let me just check. Oh, wrong one. See that? There we go. This. Here it is here. So filtered index is going to be index just where the charge amount is greater than 20. So let's have a look at it. All right, remember 1727? That's the number of IOs. Drop that table. So 1727 now. I didn't really get it down that farther, but anyway, but we did get some, and let's see, is it using that plan? Yeah, you see inc filt? Yes, it is using that. So when you have a query, what you want to do is you want to order your search arguments. You want to order the index columns according to selectivity. Which one is most selective? Which one has the higher number of distinct values? And then the less selective ones. And you want to do an include column, or you may want to do an include column. And you may even want to do a filtered index. Now, you'll probably be running a shop where they have a lot of entity framework. Entity framework will basically suck back every column. So you may want to put every column in the included part of the index. In that case, you're going to get some really wide indexes, and they can be very inefficient. You want to be very careful about applying indexes. The more indexes you apply, the greater your chances of getting parameter sniffing and getting bad execution plans. I'm going to do just one demonstration of what that is, and then we'll have a quick look at Query Store, and then I guess I'll throw it open to questions. So here we have a query. Boom. What I have here is I'm doing a year range query. Now I am doing a small query. Just as you see, this here's 2-3 days. I'm going to do do it again. And we did the year query first, and now we're going to do the 2-day first. And now we're going to do the year one. And this is taking much, much longer. And it did that many IOs. So what's going on is, if we look at the execution plan, this is using an execution plan which is more appropriate for a short one, for a short range. So SQL Server is making a very bad choice here. What I want to show you is, and there's a variety of approaches to handling this. You can alias the variables with the local variables. You can do things here. I'm doing some aliasing, so this would get around that issue. So it's new. Create. All right, let's try this now. So this will actually work optimally for both ones. So let's have a look at this. So this is the long one, long running one, still running slow, but not as bad, not the 300,000 as before. Okay, so it's an hour, and I would like to show you just something briefly about Query Store before we go. All right. So what I want to show you is what Query Store will do is it keeps metrics for your database, for your workload on a per database basis. So here we go and look at this database here, and I have this information. So here I have a workload which is running right now, and it's saying unknown. It's saying here that a lot of parallelism going on in my system. There's some latch weights. I think. Oh, 1 second. Latch weights here. Oh, that's in parallel. Here we go. Here's the parallelism. And I have some query IDs there. So I see 10946 right down there. So I type this guy in here. 10496. I think that was it. 946. And there's my query. This is my query. I see that the execution plan, I only have one execution plan, but there's some variance in it. So this time it ran in 42 milliseconds. Normally it runs in 34 milliseconds. And here is my plan here. So what I can do is I can do things like this. I can check its properties, check its memory grants. I want to look and see if I have the parameters. I don't have any parameters here, but what I'm going to do is I'm going to show you a plan. So here's a plan, very, very stable. That's not the one I wanted to show you, but let's see. Oh, no. Yeah, this is the one I want to show you. So what I'm doing is I'm looking at this particular query here, and I'm seeing a multitude of plans. So this plan has some variance, but then I have all these other plans that have been selected. Some of them are very high, some run quite low, but lots and lots of different plans have been selected. When I click on select and I go to properties, I can find that this parameter, this keyword parameter, is ppm. So if I'm trying to tune this query, I can supply the parameter value ppm to that particular query. See, it says fac ID here, fac ID. I could drill down there, and I could plug fac ID in and just start playing with that query, trying to find out what I can do to perform it. And let's have a look at some more stuff here. More query store. So queries high variation. Here we have a query. There's some variation in the plan. Have another query. I can go to properties, get various information like memory grants. I can't get parameters for this one. I can save it. And I can open it up. And here's my plan. And I can edit query text. And I can tune that query. So I may want to put that index on to make it perform better. Maybe, maybe not. The more indexes you have, slower the writes, greater chances of parameter stuffing, greater chance of plan drift. Okay, so I am gonna just quickly go through my slides. Memory grants, yeah, memory grants are killer. What happens is SQL Server has something called resource governor. We're looking at the default resource governor, and it says the memory grant percent that any query can take is 25% of your physical memory. So you may find that you'll have queries which are taking a quarter of your query, a quarter of your physical memory, of the memory allocated to SQL Server. 2 or 3 of these guys running at one time are going to bring down your system. So I've working with this one client, and they have 756 gigs of RAM. We see queries, they'll take 140 gigs of RAM. And typically what happens is they take the memory, I run this query, I see it taking 140 gigs of memory, I run it again, it's gone. They got their memory, they did their work, they went away. Everything works, but if under load, this will not work for you. Here's an analysis of wait stats, which is going on. And what happened here was we had high page latch updates. What we did, again, index, we were able to use an index and make everything run far better. So again, I showed you some of this, set statistics IO on, set statistics time on, analyze the execution plan. This will help you to understand how to where to spend time in performing, in making your query more performant. Extended events, very good way to run a lightweight trace on your system to get things like queries taking over 10,000 IOs or taking over 1 second of CPU time. Update statistics, ensure you're updating statistics on a regular basis to maximize SQL Server's chance of giving you good plans. Parameter stuffing, you can set options on the database level. Here, we see this is introduced, I think, 2014. What we can do is we can set the parameter sniffing on or off, parameter sniffing detection on or off for a particular database. And it minimizes your chance of getting parameter stuffing. Okay, so what SQL Server does is they will start to execute a plan, and they may find, well, you know, this plan that I'm running here, I'm going to use a hash join for it. And it may find, well, you know, that's when it starts to dig into that, it says, oh, this really isn't I really shouldn't use a hash join for that. Maybe I should use a merge join. So it will dynamically make changes on the fly. Sometimes it's kind of hard to see this in action, but sometimes you will see it in action, and it can speed up performance of SQL Server. Okay, I'm going to throw. I've exhausted your hour now, and probably your patience. So I'm going to throw this open to any questions you may have. Let me see. John, do we have any questions?
I have one. We just got unmuted or allowed. On one of the slides, you said where you have a where condition, like where column 1 times 20 equals column 2. If you need something like that in your where condition, is there another way to write your query to get around that?
Yeah, huh. Not that I can think of off the top of my head.
Only workaround I come up with is where you declare a parameter, do the legwork there, and then still pass it to the query, but I'm not sure that's any more efficient.
Yeah, right. So if you do have a parameter, you should multiply or divide the parameter by 20 in that case, and just make sure that you're going to get what you're looking for, because you're dealing with an int, and you may not. When you have 6 divided by 20, you're going to get 0.
Yeah.
So that's probably not what you want.
Well, a lot of what I get is, the date format. I've got to do something funny with it so I can match up one versus the other. So
right.
I'm always doing something fishy or funny with dates. But
yeah, those are hard because quite often you want to take a date time 2 and convert it to date in your calculation. So between can work for you, but between starts at like today's the 3rd. So if I do between 6/3/21 and 6/4/21, I'm not getting 6/3/21 from the first second of 6/3/21. At midnight of 6/3/21, I'm getting 6/4/21. So yeah, that's hard. One of the things you may want to do. All right, so in this case, what you're doing is that multiplication, that little bit of math that you're doing is your only thing in the where clause. So I think you're kind of stuck with that. I think you have to do the math. But if there's something else that you're doing, let's suppose you're doing some math and some date string, like for this month, you might want to take the for this month, slurp it in to a temp table, and then do your aggregation. There's a book called SQL Performance Tuning by Pedro Lopes and Pamela Hood. They're both program engineers from Microsoft. And in their chapter on performance tuning, they actually talk about how when you have to do a lot of work in your query, you may want to pre-aggregate some of that data in a temp table and then join against that temp table. So, and by doing that, you may find that your memory grants are far lower. So I was just working on an issue yesterday where I had a 40 gig memory grant, and just by pre-aggregating it into a temp table and then use it later on in a join, I was able to get that 40 gig memory grant down to something insignificant. So I would probably see if I can't do something like that, but you might be stuck with doing that. But you will probably end up getting a scan instead of seeks in that case.
Right, and that makes sense. I understand storing some of what I need in the temp table and then using it later for efficiency. I do have some processes that are doing mainly date manipulation that are slower than I would like.
Right.
You know, my initial thought was go see if the tables are indexed. Well, they're properly indexed from what I can tell, so that's not my problem. So it's probably, you know, all the interesting things I'm doing in my where clause.
Yeah, I would have to see that query to see what I could do with that. Eric Darling talks a lot about, he uses a lot of dynamic SQL. So if you have conditional logic, so if you have where column 1 is equal to column 2, or if column 1 is null, do something different. If you have these multiple or statements in your where clause, you're far better off using dynamic SQL for that. Now, sounds like what you're talking about is just a simple one argument where clause. If you can't do any creative math, when you divide the parameter, you pre-divide the parameter, or you do some date add functions on that parameter, and it is a join condition, you're probably kind of stuck. And yeah, I'm just not sure.
You've given me some ideas
Yeah.
for things to try, so I'll let somebody else ask a question.
Yeah, I've got a question.
Sure.
Yep. Probably know the answer to this one. The query store. That's not that's not going to allow me to carry my plans over for a reboot, because we're using Azure Data Warehouse, and it's quite expensive. So we have 12 hours on high for the overnight processing, and then we do a reboot and have 12 hours on low. So I'm going to guess that the entire plan cache is gone, and query store isn't going to help me with that.
Yeah, so I had a very similar question to that recently. What happens is the plans the plan guides that you select are persisted in a table, and I can't quite remember the table. So they should remain. Now, when you recycle your server, you're probably coming back with a different number of processors. So I'm not sure what kind of metrics you would get on reboot or restart that SQL Server. So I don't know if that plan would be applicable anymore. Yeah, plan drift is a real issue. And as we saw with that one picture I had, I think it's here. Yeah, we see these yellow ones. We see some plan drift on those yellow ones. We see different plans, but different, just different performance metrics. And it can be, just bringing back a different date, which will cause that to happen. But yeah, it's an internal table. I've seen some Microsoft engineers very furiously forcing plans to get the kind of performance that they want, like just forcing multiple plans, like 20 or 30 of them, in quick succession to try to fix a plan to stop plan draft. So SINA table, internal table, yeah, I believe it does survive a reboot. It may not be a wise choice or not.
Yeah.
Any other questions?
I actually shared a tweet, tweeted you with a screenshot of the runnable sleeping execution process.
Okay.
So I figured that might be good for visual learners. It's taken from a blog.
Okay, thank you.
If there are no more questions, let's,
Hi,
you
sir.
know,
Can you hear me?
I can hear you.
So I have one question. Like,
Sure.
the server is very slow, and the developers, consider it as a dev server, so they keep adding new databases. So my question is like, uh, at what point we need to consider like, adding more memory or more CPU. So in other terms, what I want to know is what are the things needs to be monitored. Is there any specific performance monitors to check? Is there any change of workload? So that that's why the server performance have gone down, um, and it's time to add more resources to that particular server.
Yeah. I face that issue all the time. So, okay, first of all, if you have disk issues, if you look at the SQL Server error log that says an IO operation has taken more than 15 seconds to complete, that really is the kiss of performance death. There's nothing you can do. You're going to be always working on a slow system. If your SQL Server error log has a lot of those messages in, I mean, you have to get faster disks. Now, CPU. So you can have some aberrant processes which are running, which are consuming all the CPU or consuming all the memory. So again, you want to kind of identify, well, is it particular queries which are bringing me down or not? And one of the things that you can do is there's code that you can write that will kill sessions that run more than a minute, whatever is applicable. You can also use Resource Governor. So what Resource Governor will do is it will throttle certain workloads. So if you find that there are workloads that are slowing everything down, you can throttle them. And what I do is I use SP who is active and I log that to a table. So if people come to you and they say, hey, this server's really slow, then you can look at that table that you persisted it to and you can find out what is slow on that system. And you may find devs are doing bad things. You may find that that there's a lot of work going on. And in that case, you may have to invest in more memory or more CPU. So just getting back to one more thought on that. So if you were an SP pressure detector, so Google an SP pressure detector and Eric Darling, E-R-I-K Darling. That tool will tell you when you're slow. Is it resource semaphore? Means you're winning on memory, or is it CPU? Is it thread pool? Meaning you're winning on threads. And that will give you an indication that you have memory problems or you have processor problems. You don't have enough processors. And then it's a matter of, well, what is taking on my processors? What is taking on my memory? But it says to you, more memory is likely going to solve this problem, unless you have some really bad queries demanding high memory grants. So I don't really have a clear-cut answer, but if you have those disk errors, disk messages, and IO operations taking more than 15 seconds to complete, and maybe it's not one IO, maybe it's like thousands of IOs, you need faster disks, there's no question. If you see resource semaphore, you have issues with memory grants, and you have to try to figure them out. And you can use the memory grant DMV to tell you which ones they are, and you can go and try to fix them. It's possibly just bad code. If you're seeing lots of thread pool, wait stats, you probably do need more CPU. And then the thing is, you may want to drop max stop to 1. And then everyone should get their CPU slice. They'll run slower, but they get their CPU slice.
Okay. Yeah.
Very, very common problem. So.
Yeah.
Great
Thank
job.
you.
I think I think we can have one more questions, and after
Sure.
that, we're gonna end the session. Just for your information, Hilary, I'm about to share my screen while you are responding to the questions. Okay.
Okay. All right. Sure.
Are there any more questions, guys? Are there any more questions? Hilary, it seems like there are no more questions. Thank you so much, guys, for attending our presentations. Hilary, it was an honor to have you, and that was an amazing sessions. I learned so much. I hope to have you next year.
Thanks, for sure.
Thank you, guys.
All right.
Bye-bye.
All right.